Hello, this is Hanson Lee doing AP Physics 1 FRQ2 version C. A is asking for the forces on each block. Let's try A. This would become Fn, this would become Fg. The normal force and the force of gravity are going to be equal. Tension is going to be slightly shorter for, let me show you why. B. This is going to be tension pulling up because of the rope. Oh, sorry. And this is going to be Fg again. The tension is going to be shorter because the block B is going to be moving down. So it's going to be the same for block A because they're the same masses and the same numbers altogether. B. The acceleration of block B is going to be the same as the acceleration of the system. So we just solve for that. What's the only force acting on the system? FGB. Mass of the system, 2m. Because A is 1, B is 1. This just becomes mg, this becomes 2ma. Get rid of the m, get rid of the 2. A is going to become g over 2. C. Time at which B strikes the floor. So we're going to be using this displacement formula in the y direction. Oh, sorry. So it's going to be h. There's going to be nothing here because it's from release from rest. Move everything over. A is just going to become g over 2 as we just found in the last part. T squared times 2 to get rid of both, times 2 over g to get rid of both. So 4h over g equals t squared. T equals square root of 4 is 2, and hg stay inside the root. It's be t1 as what they're marking it as. D. Motion of block A from t equals 0 to from this time. This is simple. A is just going to be moving horizontally right because of tension. It's going to be moving up. It's not going to be moving up or down. It's just moving horizontally right. Part E. So from B striking the floor to A leaving the table. So this is actually going to become horizontally right again, not up or down, like when it leaves the table, because like block B would be down here. The tension would still have like time. The tension would be 0 on block A because it still has length to like extend. So as A leaves the table, there's going to be no forces acting on it. So it's just going to be maintaining the same line of motion and going horizontally right. Like initially when it leaves the table though. F. Distance between the landing points of 2 blocks. Displacement x equals vi. So this is what we're using, displacement formula. There's going to be no acceleration in the x-axis when it leaves the table. So we just have to find vi and t. So vi for this is going to be vf when block B is falling. So we'll be using this formula to find the VF. So the VF for this, which is when block B is falling, is become the VI for when block A leaves the table. VI 0 is when we release from rest because it won't be moving if block B wasn't released from rest as well. So VI 0. A we found is G over 2. t we found is 2 h over g. So get rid of the 2's. Vf equals g root h over g. This will become Vi for this, by the way. And exactly because, remember, it's going to be horizontally and this is horizontally. So Vi is going to be exactly Vi. Yeah. So this is just Vi part. We need to find t. This is going to be a different time than this because this is after block B falls. So me using this formula. So there's going to be nothing in the y direction in terms of velocity because remember it's going horizontally. So it's going to be going 2h equals 1/2. A is just going to become g, different acceleration because that's the only force I on it. Equals g squared times 2 both sides by g both sides. So it's the same thing as other. 4h over g equals t squared, but we had different parts. So t equals 2 root h over g as well. For different times though. Oh yeah, we're still solving for the distance between the landing points. So let's just plug both in. G root h over g, 2 root h over g. So we're gonna skip a lot of complicated stuff. Well, I mean complicated for me, because multiplying the same thing by itself, if it's in a root, it's just going to cancel out the root because it's being squared technically, and the squares cancel out the root. So it will be g times 2 times h over g, and we have to just cancel out the g again because one on the top, one on the bottom. So the difference in the distance of the landing point of the two blocks is going to become 2h. Can you see F? Yeah. F derived an expression for tension T. So I'm going to be looking at block A, because tension is only force acted on in the x direction. This would be tension. This would be mass of A, which is going to be, and this A is going to become G over 2. So T equals M, because block A is just an M, G over 2. H. So they're going to be tripling the mass of A. So you can just use the same formula. Except that's bait, because remember that the acceleration of the system will also be affected by 3m. So we can't use this one, but we can use this one with a different A and a different MA. So just write that for later. Let's just find the acceleration, the new one. So the only force acting on the system is just gonna be Fg of B equals the new mass of the system. So it actually does change for m, because 3 plus 1 A. So this is just going to become mg equals 4ma. Sorry. A is going to become g over 4, which is different. So now we can actually find what the new tension is. So A is going to become 3m now, and this is going to become g over 4. So tension equals 3mg over 4. So this is going to be greater than our old tension, because 3 over 4 is greater than 1/2. And so it's going to become, so the tension is going to increase. And you can just look at that because you're trying to move something heavier in terms of mass. So increase, yeah. Let me show you I. Okay. I. So the hanging mass to be doubled to 2m. At the top, I think it's going to increase, and the physics doing is going to be right, because the acceleration is definitely going to increase with 2m being greater. But let's just show you why. So a lot of things are going to change with 2m. So the acceleration is going to change. New mass of the system is become 3m. Trying to find a new A. This will become 2mg 3ma, go to the m, 3, so A equals 2/3 g, which is already greater than g over 2, because 2/3 is greater than 1/2. Doing the same steps as this with different variables. So this is going to become the same thing we did for part C. It's going to be 0. It's still going to be H. This is going to be 1/2. 2/3 G T squared. So times 2 cancel this out. Times 3 over 2G to cancel this out. We get 6H over 2G equals T squared. T equals root 6H 2G. And then, sorry, just do it for part F, because they're saying that F is gonna increase, so we're just gonna see that play out. So there's gonna be no acceleration as in the x direction as A leaves the table. Let's find VI. There's gonna be VF for this part. VI is 0, VF is gonna be 2 over 3G. This is, let me just make it look better. 2G over 3 times our new time, which is root 6H over 2G. So we're already getting like big numbers getting multiplied. Let me put in my calculator. Oh, so what we get is 1.15. So VF equals 1.15 g root h over g. So in our last one, we got just g root h over g. This is going to be 1.15 times that, which is going to be more. So for the t, we can just use this answer because nothing is changing. Not the height of the table, not VIY is still 0, and the acceleration is still g, and what we're trying to find is t. So we can actually just do this now, vi times t. So we get, so last time we did this, g root h over g times 2 root h over g. So we actually got the same thing, but times 1.15, which is going to increase the answer of f. So I do agree with the physics student that our answer in part F will increase. But you could have just looked at it and saw that the acceleration is going to be faster and then made a guess. But I agree. That's it.